Alrighty, so onward to Chapter 7. Additional information about object-oriented programming. We already know a lot of this stuff. Assigning a reference. We know how to assign a reference. Testing objects for equality. Now this is extremely important. We need to start adding a method to our objects to allow them to be tested against each other. Just like if you want to compare two strings. You cannot use double equal signs to compare two strings in Java, unlike in C++ or in Python. Passing references as arguments, well, I've already talked about that. Method call chaining, well, that's worth talking about. Overloaded methods, we've brushed upon that. Constructors, we've talked about that. And overloaded constructors, we have talked about that. So there's really only a couple of things here that we actually need to drill into, although all of it is good information. You've seen a sneak preview. Now you need to read the textbook and get the proper introduction to it. Let's take a look. If I can zoom in, that'd be better. So this declares the reference variable, car. This instantiates the object. That instantiates the object without storing it in the reference. That is a proper object instantiation. Well, I shouldn't say proper, but it is a core fundamental. Use the new keyword, you create the class, and then you store the result of that in the reference variable. And then you can start assigning values. Although since we're supposed to be using getters and setters, setting that value would instead be a call to set year. And so when this happens, space is allocated in memory for the car reference variable, which will hold the address of the object, but it doesn't have any address in it yet at that point. Then the new keyword runs out, and on what's called the heap, it goes and allocates all the memory and fills in all the variables for that particular object. And then the address to that memory location on the heap is stored in that variable. Then every time we try to refer to it like that, then it accesses that particular memory address and then goes to that variable, that member of it, and can access it there. So out in memory, you actually have two different sets of memory that every program has access to. One is called the stack, one is called the heap. The stack is where variables are created, and the heap is where objects are created. The stack is where parameter variables and regular variables are created, not member variables. Those are created out on the heap. So we create a variable named car. It's located on the stack somewhere. And then we create new car. It runs out, finds some spot out in the heap, creates space for it. Apparently this thing was supposed to have 3 different members, one of them being a year, and then that memory address will get assigned to the reference variable. So the reference variable is just another slot in memory that contains that. So if you create one reference variable and assign it to another, both reference variables point to the same object. With both reference variables pointing to the same object, if the object is updated by one of the reference variables, then the other reference variable, since it's pointing to the same object, gets the same changes. Just like you have 2 signs pointing to your house, if you paint your house red, you now have 2 signs, 2 reference variables pointing to a red house. And this becomes important when we start talking about arrays, because when you stick an item into an array, if it's a reference, like if it's an array of, cars or something like that, then you're not putting copies of that data in there. You're putting the original pieces of data in there. And so then if later on you go and you change that car object, it's magically changed for the reference in the array as well. When I say magic, it's just because the item in the array is an address pointing to the same object that your reference variable was. So suppose you want to create 2 car objects that are the same except for the car. So you think you're going to create the first car, copy the first car to the second car, and then update the second car's color instance. Will this do it? Okay, and we have a car there, right? Stacy's car, and then we create John car. John car is a new car. That creates an object, stores a reference to it in John car. John car's variables get set to Toyota 2008 silver, and then we set Stacy car equals John car. Excuse me. So that copies the reference from John car to Stacy car. Does that actually create a new object? Do we now have two car objects? No, we still have one car object. We just have two different names for it, two different references for it. So for Stacy's car, we do Stacy car.setColor peach. Well, if we print out John car.color, it's also going to say peach now, just because we have two references to the same object, two references to the same data, just like two signs pointing to the same house. So the problem with the previous slide's code is that this creates two references to point to the same single car object. So you would need to create a second car object. You might want to create a method that would allow you to copy or to clone one car object and create another. You might want to create a constructor where you could pass in one car object and it would copy that information and place it into another. So if you want to make a copy of the reference variable, well, this is worded incorrectly. If you want to make a copy of the object, you should not assign the reference to another reference. Instead, you should instantiate a new object and then assign the two objects instance variables one at a time. So you could create John car equals new car, Stacy car equals new car, and then John car.make, or John car, set make, set year, and set color. And then we would need to set Stacy car's make, year, and color to the same thing. Maybe about time to do some code for that. We're on lecture G. Let's create a new lecture. Make it an ant module. Doesn't say ant here because I'm running NetBeans 8 rather than the version that you're running. But this is using the ant build system. I'm going to call it lecture G. For the main class, I'm going to remove the package declaration. So if you can see what I'm doing down there, I'm going to delete all that before the dot, including the dot. All right, and I always say this, but every object should go in its own file. You know what, maybe I'll do that. I don't know. Maybe I'm feeling ambitious and want to put, no. I'm going to go and do the bad programming and create this. So I'm going to make a point class, which has just got an X and a Y coordinate in it. Now there really is a point class lurking somewhere else in the Java, library. So instead I'm going to call it my point. So class my point, and it's got two values, right? Int X, comma Y. Those are its two members, coordinates in space. Could encapsulate those. You know how easy it is to encapsulate. Just choose those variables, choose refactor, encapsulate fields. And what do you know? The following warnings and errors were found. Cannot refactor. I wonder why. Not quite sure I've seen that. Maybe because I haven't saved it? That's peculiar. Command S. Try once more. Highlight those. Refactor. Encapsulate. Oh, okay. I just hadn't saved it. What do you know? I'm going to tell it not to create the Java doc. So I set that to none. I would like for the placement of the getters and setters to be at the bottom. No, it's not letting me set that. I guess I'll just cut and paste. All right, and then click refactor. I'm going to move my variables up to the top. I'll highlight those. Move them back up to the top. Now I have my getters and setters. If I wanted to make everything concise, you've seen me do this before. If you ever learn about the language C#, it's got a way of building these getters and setters in such a way. Never mind. It does not take so much typing. All right, just a little bit more. It's easy to delete that closing parentheses when I'm backspacing, so I keep having to add it. First thing I'm going to do after I do this is build my project, make sure I have not introduced any. And there, I deleted a semicolon. Make sure I have not introduced any errors. All right, again, that's just a personal idiosyncratic style of doing these. I think it gives us enough information about the getters and the setters so that we can clearly tell what's going on. Getters being the accessors, setters being the mutators. All right, I'm going to build it, hammer and broom it, make sure I have not introduced any syntax errors. Okay, so if I was going to create two objects, maybe down in main, right? My point P1 comma P2. I'm going to have 2 points. P1 dot set x. The x value of that point is 10. P1 dot set y. The x value, the y value of that point is 30. Wouldn't it be nifty to be able to do this? P1 dot set xy parentheses 10 comma 30. If I was ambitious, I'd come up here and I'd create a method called setXY that would let me set both of those values at the same time. Just because that's how we think about points, right? You know, the x position of it and the y position of it. Why don't we go and do that? Kind of a multi-setter. I don't know if there's a term for a multi-setter. So public void setXY needs to take 2 parameters. Int x comma int y, so that we can pass in 2 arguments to fill in those parameter variables. So on the next line, I'm not going to do this because it's more than one line of code. So I'm not going to do this little thing about putting it all on one line. So this dot x equals x, this dot y equals y. And now I can just call set x and set y like that. Right? I don't have to call them individually. I'm getting some kind of error here. Am I not? Am I seeing a problem here? P1 may not have been initialized. Well, that is so true. I never created the object. How silly of me. P1 equals new, capital M, my point, parentheses in parentheses. We also could have just created a constructor that would accept, 10 comma 20 like that. We didn't. So I'm going to live with having that setXY function. Kind of makes sense to me. Now, if we want to make another one that is a duplicate of that, right, P2 is supposed to point to a new object with the same data. P2 equals new my point, parentheses in parentheses, semicolon. And then P2 dot set x, parentheses, P1 dot get x, parentheses in parentheses in parentheses, semicolon. See what's happening? We're getting the value of P1's x, and we're putting it into P2's x. Going to do the same thing for y. P1 dot set capital Y. Excuse me. Did I say P1? P2 dot set y parentheses. P1 dot get y open parentheses close parentheses semicolon. So I'm going to add a comment here as to what's going on. Create a second object with the same values as the first. And I would consider calling that clone, right? Where we've kind of cloned the object. We've copied the object. Copying the object, I don't like that term so much. We've created a brand new object and then we put the new values in it that are the same as the original values. You know what, if we have P1 set X and P1 set Y being done in this line, you may as well comment these out. All right, let's find out if these two objects are the same. We want to compare them. This is how not to do it. If P1 equals P2, curly brace, system.out.println, parentheses, quote. You know, we could do this in a shorter fashion. How about just do this? No, I kind of like leaving it like that. I'm going to leave it like that. So system.outline.println, outline, system. How about we do a little bit better typing? system.out.println, parentheses, P1 equals P2, end quote, in parentheses, semicolon. Else, they're not the same. I'm going to remove these curly braces because these blocks of code only have one line on them. So else, system.out.println, parentheses, P1 is different than or from P2. End quote, in parentheses, semicolon. Let's take some bets as to what's going to happen. Looks like it ought to just be comparing them, right? They've got the same data. It ought to say that they're the same. Not going to work. So I'm going to run it. P1 is different than P2. Is it than or from? What's good English? Anyways, why are they different? It's because P1 is an address, points to an object. P2 is an address, right? Remember the two signs pointing to the same house? Are they the same signs? No, they're not the same signs, and that's all that this is checking. Just like if you have two strings. If you do this, string S1 equals, quote, yes, end quotes, comma, S2 equals, quote, no, end quote, comma, and let's make it yes as well, right? This is not the correct way to compare them. It might actually trigger and say that they're true, but that would be a coincidence. If we do this, if S1 equals S2, all it's doing is comparing the two references. That is not the correct way to compare strings. And I know we've talked about that in the past. Either you and I in one of my classes or you and somebody else in another class. If parentheses S1 dot equals parentheses S2 in parentheses, that is the correct way. So this is incorrect. That is correct. I'm glad y'all know that my prescription is ready. Here we go. That's the correct way to compare two strings. Why don't we even add a comment to that effect? Use dot equals, not equals equals to compare strings or any objects. So can we do that? Can we change if P1 equals P2 to if P1 dot equals P2? I believe that there is a default, or not, I shouldn't say default, but I believe that Java has already provided us with a dot equals method. And I also believe that it is not a good version of it. Well, let's see if it works. If P1 dot equals parentheses P2 in parentheses. And then I commented this out because this is incorrect. Let's hammer and broom it. Let's run it. It's still saying that they're different, right? But we call dot equals just like we did with strings. Well, the problem is that all objects inherit from a base class. The base class is called object. The object class provides a dot equals method. But that dot equals method doesn't know anything about our data, right? How could it? You know, when the people who wrote Java created the default object class, they didn't know that we're going to be creating a point with X and Y data. So that's not going to work either. How are we going to get that to work? Neither one of those worked. And as a matter of fact, I may just delete this one entirely so as to not even tempt us into thinking that that's a good way to do it without some additional effort. Here's what we have to do. If p1.get parentheses x, why did you fill that in? p1.get x parentheses in parentheses equals p2.get x parentheses in parentheses. You can see where this is going. We're also going to have to compare y. Ampersand, ampersand, p1.get y parentheses. Yeah, and we could be choosing these from the, the helping tips that are coming up. Equals p2.get y parentheses in parentheses. See, we have to compare the data elements by hand. That's a bit tedious. What if this thing had 3 data elements? It was an x, y, and a z coordinate. What if it was a vector that had an x, y, z coordinate and a magnitude going in some other x, y, and z direction? Right. That's 7 pieces of data. What if it is, an employee record with 20 pieces of data in it, 20 member variables? Would we want to have to do that every time we wanted to check to see if they were equal? No. That's pretty lame. Does this collection of slides talk about dot equals? And it does. Talks about writing a dot equals method so that we can compare the two objects. Oh, they don't give us a solution. Is it tucked down here in the notes? Yeah, here's their solution. I might do it a little bit different than that. We're going to go and add a dot equals method so that we can compare the two objects. We're going to have to go up to the point class. We need a new method. If parentheses, no. What am I doing? We're defining an object, a method. Public. Now this needs to return true or false, so it's Boolean. Boolean equals, you don't put the dot there, right? That's not part of the name, that's just part of the syntax. And what does it take? It needs to take a reference to another point. Public Boolean equals, a my point. And I'm going to call it other as opposed to this. So you see what's going on here. We're going to have an equals method that we can pass in as an argument, a different object, different reference, which will get stored into the other parameter variable. And all we have to do is something like this. If parentheses in parentheses. Same kind of business we had downstairs. But I might do it a little bit different. If parentheses, this dot x equals other dot x. But I'm going to change that to if this dot x not equal to other dot x, return false, because it's obviously not the same. If parentheses this dot y not equals to other dot y, in parentheses, return false. If we had more variables, more members, we'd add those. So, but if we get to this point, if we've checked all the variables and they are not different, then we know that they are the same, so we can return true. Now we can compare those objects successfully. So here, instead of if P1 is equal to P2, I guess I should have left my dot equals method. Check if parentheses P1 dot equals parentheses P2 in parentheses parentheses. I may comment this one out as well and move it up above it, right? Because this is a valid way. It's just kind of a long, tedious way that you would not want to have to repeat every time you wanted to compare those objects. And if you were going to let another developer use your class, you would not want to make them figure out that that's the only way to compare the two objects. So I'm going to add a comment that this is good, but can be done much better by creating a dot equals method that effectively does the same thing, does the same checks. And this is just terrible. Bad. Fails. Not how to compare two objects. All right, and this is the correct way. Let's build and run it and hope it works. Then I'll scroll back up and give everybody a chance to type in the code if you haven't already or you're getting syntax errors. So hammer and broom it, build successful, run it, and the objects are now considered the same because they have the same data. If we changed one of them, right, P1.set parentheses X, wait, P1 set capital X parentheses 10,000 in parentheses. Now they're not going to be the same. It should not say P1 equals P2 because they're not. P1 is different. I think I'm going to change that to different than P2. I believe that's better English. All right. To recap the code as we have it so far. Here's what our myPoint method looks like. If it will not compile, if it has a syntax error, you're going to want to pause the recording and compare it to your own if you are typing in the code. If not, whatever. And then down here is where we actually create the objects. Here's where we make a copy of it. Let's add a comment to that effect. Oh, I guess I did. Create a second object with the same values as the first, so I have created that comment. And then here's how we compared them using our classes dot equals method. All right, things that might make things easier. Wouldn't it be neat if we could do this? I may not even do it right now. I'm just going to kind of tuck it in your head, I think. P2 equals new my point parentheses P1. Wouldn't that be pretty dang neat, right? Then we don't have to do all this business. That would be really nice if we had like 10 different data members of the class. That way every time we create an object and we want to do a new one, we could do that. Or at the very least, if we did this, oh, by the way, that was supposed to be P1, right? So that we could copy that in. Doesn't much matter at this point. We don't even have that method. Wouldn't that be neat? Or what if we did this? What if we added a .clone method? P2 is equal to P1.clone. Not close. Clone parentheses P1. Well, we don't even need to do that. There we go. So we could go and add a method called clone that would create a new point and return it. Or you could just call it copy, right? If you like the term copy better. So what would that constructor business look like? Remember what a constructor is. It's just a method that has the same name as the object, as the class, and it sets the member variables. You can have a custom constructor that accepts parameters, right? We didn't have to do it like this. We could have done, P1 is equal to new myPoint, and then provided a constructor, a custom constructor that would allow us to pass those arguments in. But we didn't. So I wonder why we're creating a constructor that'll accept a point. Maybe I'll leave that alone. Am I gonna? No, we're gonna actually do it. Let's add some constructors. Let's flesh this out to be like a pretty good class. We need a default constructor so that our code doesn't break when we add the custom constructor. I mean, we can always prove that that's the case. Public myPoint, parentheses in parentheses, and it doesn't need to do anything. It's just a default constructor. Or we could set x and y to default values, like 0 or -1 or something. Honestly, they default to 0 already, so that's good enough. Now let's create a constructor that accepts an x and a y value. Public myPoint, parentheses, int x, comma, int y, in parentheses. This dot x equals x, semicolon. This dot y equals y, semicolon. And let's create the constructor that accepts a point. Public myPoint, parentheses, and it's going to take another point, so myPoint space other, in parentheses. This dot x equals other dot x, semicolon. This dot y equals other dot y, semicolon. Now let's play with those constructors. We have two new kinds of constructors. We may as well use them. So down here, maybe at the bottom, why not create a couple more objects? MyPoint P3 equals new MyPoint 20, 200, in parentheses, semicolon. And then MyPoint P4 equals new MyPoint, parentheses, P3, in parentheses. And you will see that the same idea is used by classes that Java provides. For example, the string class. If we wanted to make a third string that was a copy of one of these strings, if we didn't know that we could just use the assignment operator, then we would do string s3 equals new capital S string, parentheses, s1. Now we have a new string that is a copy of the original. You don't need to do it that way because Java does something special with strings. Strings are so-called immutable. They cannot be changed. And so the references of them can just be passed directly. You do not have to create new objects. And that's due to the magic of the library that Java gave us, string class. So we have our two custom constructors. If we had not provided the default constructor, it would break this code, this line of code, and this line of code. And I know I've done this demonstration before. If I come up here, comment out the default constructor, hammer and broom it, it's telling me that those lines of code are errors. If I scroll up, pull up the error list, I can scroll down and confirm that that's a fact, right? Wrong, that doesn't work. And wrong, that doesn't work. So I'm going to go and uncomment out my default constructor. Strictly speaking, if we want to get 100% computer science accurate, this is not a default constructor. It is a custom constructor that we provided that emulates the default constructor that Java gives us when we do not provide any other constructors. But default constructor is close enough, right? Doesn't accept any parameters, doesn't set any values, good enough. It's a default constructor. Let's make sure we fixed it. Hammer and broom. Alrighty, so what have we learned so far? To compare two objects, or to enable the comparison of two objects, you should provide a dot equals method. Because you cannot use equals equals to compare reference variables or to compare objects. A reference variable is not an object, but it points to it, so it's easy to fall into the habit of talking about it as though it were. So back to Professor Thompson's rules, guidelines for creating classes, /star. Variables private or data private. Members methods public. That's the first rule. Data encapsulation. And then 2, provide getters and setters, which you have to do since the data is now private. Which you know, we're smart enough to know that the book is calling them accessors and mutators. All right. 3, add constructors if it will make the class easier to use. Kind of a rule 3.5 would be add a default constructor if you add a parameterized constructor, so that people can create a class without knowing that they have to pass data in like that. Add a toString method to enable printing the object, printing information about it. A new one. Add a dot equals method to enable comparing objects. And 6, you may want to add a specialized constructor that will clone the object. Add a constructor that lets the code clone the object. I'm not providing too many details in the guidelines. I wonder if I could get away with just calling it a clone constructor. We could have written it as a clone method. What would a clone method look like? It'd look an awful lot like this, but it would look like this. It has to return a point. So public myPoint space clone, parentheses, myPoint other, in parentheses. Then it just does the same thing, but we have to make the object first, right? So myPoint new point equals new myPoint, parentheses in parentheses, and then this dot x, or no, excuse me, new point dot x equals other dot x, new point dot y equals other dot y, and then return the new point reference. This would let us do things like myPoint p2 equals p1 dot clone. Now that I've typed all that, am I going to delete it? I don't know. I'm just going to say I recommend doing this with the constructor shown right above, rather than a dot clone method. So let's go back to the PowerPoint. See what else we want to talk from the chapter, talk about. I believe the next thing we're going to do is call chaining. Call chaining allows you, well, why don't we go and look. Testing objects for equality. Can't use double equals. Does not work. Well, when I say it does not work, if you really do want to test to see if they're pointing to the same object, then it would work. You usually want to compare the contents of two objects, so you have to provide a dot equals method. If you go back and look at our code, it's now giving us a warning about the dot equals method. Or is it not? NetBeans is not showing me all the warnings that I expected to. Probably because dot equals is expecting an object rather than a my point. If we want to write a 100% true dot equals method, we'd have to go to a little bit more trouble. I don't think I'm going to do that. Leave it alone. What that would look like would be equals parentheses object space other, and then the first line of code would need to be to cast this object to this one. So before that, we should check to see if it's of the correct type. Now this is going way beyond what we've talked about at this point, but you can compare the types of the objects the objects to find out what class they are. And if they are not of the same type, you immediately return false because they can't be equals. Another thing you could do is if this equals other, then they're pointing to the same address. And so they're absolutely the same object. Don't even need to do the rest of the comparisons. That would not be a bad thing to tack on right here. So while we're thinking about it, if this equals other, end quote, return true. Special case, they really are the same object. Well, why did I say false when I'm meant to be typing in true? There we go. That's a little bit better. It's not a textbook perfect equals method. Maybe good enough as far as this textbook is concerned. Certainly good enough for our coding now. I wonder what this little warning is. This if statement is redundant. Show hints. Well, no, it's not. It absolutely is not redundant. It's not telling us how to fix it. The book shows us a different way of writing these, You don't always have to fix every warning. To the PowerPoint. How long have we gone? I don't want to make this like, more than an hour and a half or something. "43 minutes. Let's keep going. So going on to slide 14. 15. So it sure is nice that they don't provide the code for an equals, but down here in the comments they do. No, they don't. This is an alternate method. Not digging that. Skip that. By the way, I would be uploading the fresh PowerPoints, which will not have the random, mysterious instructors' comments that they tacked on, to the bottom here. Although they're sometimes useful, they're sometimes pretty strange. So passing references as arguments. We have talked about that. I talked about it pretty extensively last lecture. When you pass a reference in, it's not the object itself. It's a reference to it, but you can use it to change and to access the original object. That's totally fine, but you cannot modify that variable itself. So, for example, this is really not going to be a useful method, but if I did this, public void something, parentheses, and it took a my point, my point P in parentheses. We can do this, P dot set X parentheses, and set a value. That works just fine because it uses this reference to access that element, that member. But we can't do this. We can't make a brand new object and then pass it back, right? Have it mysteriously get passed back somehow. No, because this is a copy of the original reference, and if we modify that copy of it, if we reassign it, then in the code down here, when we do something parentheses P1 in parentheses, that's probably going to give me an error because I'm using an uninitialized variable, unassigned variable. But anyways, when we come up here and we change the value of P, it's not going to have changed the value of P1, right? Not going to point to an entirely new object. If you want to access that entirely new object, you would need to return it. And then you would need to change its type to my point. Now that's a silly function. If we really want to demonstrate that, let's put it down at the bottom or something where it's not nearly as important. Yeah, I guess I could do it here. My point P0 equals new my point parentheses in parentheses. This should have a better name than something. Can't quite come up with it because it's a pretty silly function. And then P0 equals something parentheses. And by the way, I didn't make this static, so that's an error. I'm going to have to go back and modify that. Something P0. And so it created a new object and then it returned it. I guess we could change the order of this like that. We return that reference. We need to make this a public static, my point. Why are we making it static? Because we're trying to invoke it from a static context right there. All right. So something is still a stupid name for it, and that's bugging me. How about make new point, right? And then make new point, or copy point, right? Because it is a new copy of it. No, it's not. It's a stupid thing, so I'm just going to call it something. I'm going to leave it called something because it's just a demo. Add a comment. This method just demonstrates creating a new point, creating a new object in a method, and then returning a reference to that new object. Ignore the stupid name. I could call it make new. But in that case, why are we passing in the original object? Okay. Still, gonna leave it alone. Back to the PowerPoint. Passing references as arguments, we know how to do that. The parameter just needs to be defined of the type of the class, just like we did here, right? This method is going to take a point reference, a my point reference, so that's what we set the parameter as, so that we could pass it in as an argument. Maybe it would have made more sense to make it a new point, reference. But the idea was to show you how to change the thing that was being passed to it, or not change it, but actually reassign it completely. And that's how you would do it. It may be slightly too esoteric. I hope it makes sense. I'm pretty sure we'll come across a need to mention it in the future. And then a swapping algorithm. If you're going to swap two variables, this is totally off. That's why you called it aside, off the map of the topic. If you have, a is equal to 3, or let's do different variables than what we have, and int b is equal to 20. Why don't we actually do this in our code so that it's there in our notes forever and ever. Go here, down here at the bottom, I'm going to make 2. Well, like if we wanted to swap P3 and P4, how could we do it? You have to create a temporary variable. Just like if we have int x is equal to 7, int y is equal to 8. You want to swap those values. Here's what you cannot do. Y is equal to x. X is equal to y. That's totally wrong, right? Because by the time we do y is equal to x, they're the same value. Nothing to swap anymore. 7 would have got copied in here. We no longer have any 8s involved. So you've got to create a temporary variable. Int temp is equal to x. X is equal to y. Y is equal to temp. Now we have swapped them. You use a temporary variable, did I spell temporary right, to store one of the values to perform the swap. Here we go. Method call chaining. What is method call chaining? Method call chaining allows us to do this. P1.set x to 10 in parentheses. Oh, and by the way, I really want to change y in the same command. Set y, 10 parentheses. And then I want to, we did not add a toStrings method. But if we had, then we could invoke it like this, right? And then we could have created a string. String s3 equals p1.setx dot setY dot toString. You see what we did? We called a whole bunch of methods all in one line rather than p1.setx, p1.setY, and then string s3 equals p1.toString. But we're getting an error here. How do you enable call chaining? Here's how you do it. I kind of liked my point class. We kind of cluttered it up a bit too much. But to demonstrate call chaining, why don't we create a new class? Class name, parentheses in parentheses. It's going to have two strings, right? String f name, comma, L name for first name, last name. That's an L, not a 1. Let's add the getters and setters via the nice cheaty way. So I'm going to save my document, Command S. I'm going to refactor it in order to encapsulate the fields. I really wish it would let me set the insertion point underneath everything. Still don't understand why that's not being allowed. Refactor it. I'm going to move my two member variables, instance variables, back up to the top. There we go. To get this to work, the method has to return the this reference rather than void. Now, get name and get L name and get F name will not be able to be chained because they are returning strings. They cannot return the this reference. But set F name can, and set L name can. So instead of being declared as type void, set F name is going to be declared as of type name, the name of the class. Same thing down here. set LName can be, instead of void, set it to name. Each one of them now actually has to return the this reference. If I do Command S, I'm going to get some errors because we're not returning anything. So we need to add return this. Same thing for this function, this method, excuse me, return this. And let's add a print method. Public name print, parentheses in parentheses. And we're just got a system.out.println the f name plus a space, quote, space, quote, plus the last name. End quote in parentheses. And then we, again, since it's not void, since it's returning a reference to the object itself, we've got to return this. Now we can chain these guys. Let's make a new string. Right up at the top of main. Not a new string, it's a name. So name in1 equals new capital N name. And then let's chain our calls. In1 dot set f name to Bob, end quote, in parentheses, dot set L name. What's his last name? Williams, end quote, in parentheses, dot print, parentheses in parentheses. Let's run it, see what we get. Hammer and Broom did, no errors. And in fact, it worked, right? It set the first name, it set the last name, and then it printed it out all in one command. Now, honestly, until I started teaching the class, I never really cared about call chaining. I still don't care about call chaining. This will probably be the only lecture where I actually demonstrate it, unless we come up with some cool reason to do it. Well, here we go, right? We have an f name that returns this reference. We have the set L name, which returns this reference. We have the print function, which returns this reference. So we can chain them. And you know what? I guess I could make, a new professor's guideline, which is that all your void functions should instead return this reference, right? Which means that they would no longer be void. You'd have to change that type from void to the name of the class. If you feel like it, if you feel like impressing your friends and frightening your enemies, feel free to do that to support call chaining. Let's look at the code again so that if you were actually typing it in, you'd have a good chance of getting it to work. It's not all on one page yet, all on one screen, so I'm going to delete the blank lines to try to get it there. There we go. That's the entire method. Excuse me, that's the entire class. How far are we now? Almost an hour? Is there anything else in the chapter that we haven't already covered in our last lecture? This is just demonstrating call chaining. Set make, set year, and print. Remarkably similar to what I just did. Probably because I've taught to that slide before. So instead of being declared as void, set make needs to be declared as that type. Now this is a horrible method declaration because that does not work, right? If you put this into your code, that'd be a syntax error. You'd have to, put all that stuff in there and then return this reference. So if I'd written this slide, I would have removed the semicolon. Method call chaining is optional. Why bother with it? Often leads to more elegant code. It's more compact. Results in code that's easier to understand, I suppose. Seems like a matter of opinion. I don't know. Maybe that's better than setting each point individually. It's up to you. Judgment call. And then method overloading. We've talked about overloading a little bit, I believe. It's probably important enough to dedicate an entire lecture to, or at least talking more about than I want to right now after your eyes are starting to roll up. So let's prove to ourselves, though, that we actually understand the concept. We have already been using method overloading without calling it that. Method overloading is when you provide functions with the same name, methods with the same name, but different parameter lists. We have 3 different myPoint functions, myPoint methods. We have 3 different constructors. One of them doesn't accept any parameters, one accepts a pair of ints, and one accepts a reference to an object. That's overloading. Overloading is not bad, right? The engines are overloaded. That sounds bad. The methods are overloaded. It's good. Makes it easier to use the class if you can just use the same function. For example, I don't know, but we have a set XY function which accepts ints. What if you wanted to write another set XY function which would allow you to pass in data like this? I'm not going to actually do it. But what if I wanted to do this? Set XY, parentheses, quote, 100, 109, end quote, quote, 20, end quote, right? We could provide a second set XY method that accepted strings, turn those into integers, and then set the values. That would give the programmer using our class more flexibility about how they called that function. They could pass it with integers and they could pass it with strings. And delete that. So we will hit that again. I think this is far enough. We need to create a little bit of a homework over this topic. What do I want you to do? Why don't we put the homework inside a comment like that? We have played with creating, I believe, a pet class in the past. Let's go look at the other homework assignments. Uno momento.